Hello and welcome to The Future is Spoken, produced by the Digital Assistant Academy. This show accompanies the Digital Assistant Academy's course entitled Voice Interaction Design. Natural language understanding is a natural language processing field focused on machines' comprehension of instructions and input made in text or speech. The field studies artificial intelligence and its ability to interact with humans based on its understanding of both simple and complex language inputs. Natural language understanding is studied both in things as small as one-word or short phrase commands and structures as large as poems, letters, and even literature. One of the significant goals in natural language understanding is creating AI tools that can communicate with humans organically for various purposes. The field has already produced important milestones, including Apple's Siri, Amazon Alexa, Google Assistant, and Microsoft's Cortana. A lot goes into making a natural language system. In today's episode, Shyamala Praga speaks with Jeff Adams on the art of crafting natural conversations. Enjoy the show.
Welcome to The Future is Spoken. And today we have a very special guest with us, Jeff Adams from Cobalt. And Jeff will be talking with us about how we can craft natural conversations for the bot. So welcome, Jeff. How are you doing today?
I'm great. Thank you. Thank you for having me here.
Yeah, it's our pleasure. I'm so looking forward to this episode. So Jeff, why don't you tell us about your background? How did you get into speech?
Well, I've been doing speech technology for 25 years, almost 26 years now. I started with a small speech company in Boston, and through a series of acquisitions that became Nuance, I left there to join a small startup in North Carolina, and that startup was acquired by Amazon. So that was the next part of the roller coaster. I ended up working at Amazon on the Alexa product before Alexa was launched. And then when Alexa was launched, I left Amazon to found Cobalt Speech and Language, which is where I am now, a company that does speech technology in support of other companies.
That's interesting. We have so much in common. But it's the other way around. I used to work for Amazon first and got to briefly work on the Gen 1 and Gen 2 of Alexa. And then I moved to Nuance. Not Nuance, I used to work for VoiceBox, which was acquired by Nuance.
Right.
It's interesting. It's interesting. So tell us a little bit more about Cobalt. What does it do?
So Cobalt really has two main assets. One, we have a collection of speech and language processing tools and software, things like state-of-the-art speech recognition, speech synthesis, dialogue systems, different kinds of analytics for voice or text. And so that's the first asset we have, is this set of software. And the other thing we have is a set of 15 or 20 very smart PhD, master's degree level speech engineers and scientists that have built those tools, and they're now around. And we, for the most part, we work with companies that are looking for some technology, and we can extend, customize, tweak, tune, whatever. If companies need things to run on a specific platform or in a certain configuration or be tuned for a particular application, we do that for them. So we are a company that licenses technology and also customizes and extends that technology.
That's interesting. So do you have your own conversation platform, your speech recognition systems, or do you support the companies who want these kind of technologies?
So we do whatever is needed. Our mandate is to help anyone with any speech problem or language problem that they have, but we prefer to work with our own technology. We have all of our own in-house IP, and that allows us to get under the hood and change things, modify things if we need to. Typically, if you're working with someone else's technology, they only expose certain controls, and that fetters you, that limits what you're able to do. So we prefer to work with our own just because it gives us more flexibility, and we find that we can make our customers happier that way. But in some cases, our customers are committed for some reason because of a partnership or a previous investment to some particular technology, and then we help them work with what they have.
That's cool. That's cool. So your background from Amazon and other companies into the speech recognition and the NLP systems, like building those systems, could you tell us how can one design natural conversations?
Right. Well, there's an art to that, and if I could tell you in 5 minutes how to do it, a lot of people would be out of jobs. There's a lot to it. I think one way to approach it, however, is to ask ourselves, if I were a human trying to help someone with a particular task, how would I be most helpful and not get in the way? So you think about what are the different ways that you'd want to understand a system? How chatty should it be? How much should it? People have different personalities, and one of the first questions is you have to ask yourself, what is the personality I want in this assistant? Should it be conversational and chatty, friendly, or should it be more professional and a little bit aloof? And how you answer those questions, and there's no right answer for everyone, but how you answer those questions then will inform the design process of what should you. I'll give you one example. I think when we built Alexa, we made a lot of decisions I'm very happy with, but there's one thing that I'm not happy with. I use Alexa to listen to music a lot, and I frequently say, Alexa, play this song, and there's some song that's, maybe I got it stuck in my head and I want to hear it, and I say, play this song. And often, if I wasn't paying attention, maybe that song isn't in the library or isn't accessible. It drives me crazy when Alexa says, oh, I couldn't find that song, but here's another song you might be interested in. I don't want another song. And so but in another situation and for another person, that might be what they want. So you have to think about, what's the personality of my assistant? How conversational? How much should it take initiative? All of these questions, and get that down first. And then you can go about designing conversations and so forth. And the specifics of how you design those conversations will vary according to the tools that you're using and whatever platform you're using.
That brings up an interesting point. Every user is so different. Like you mentioned, maybe you don't like getting those kind of options, but then speaking with a lot of people myself, I realized some people are like, well, although I was wanting to listen to a music and I did not get the same music, at least I'm getting something else, so I'll be happy with it.
Yeah.
So different people and have different choices. How do you design a solution which can cater to all of these different users? Because not all the 5 fingers are the same.
Yeah, that's a hard question, because everyone has such different needs and people interact with this in different ways. One option is to give the user some ability to control that, to give the user some ability to say, hey, don't play music that I didn't ask for, or something like that. Or to learn, if every time a user asks, I'm going to stay with that example, even though there's many other similar examples we could be talking about. But if every time I ask for a song and Alexa plays a different song, trying to just give me some music, and if every time I say, stop, I don't want to hear that, it should learn after 1 or 2 times that, oh, he doesn't like that. And so I think we need to learn how to build systems that are adaptive to users, that pay attention to the kinds of how they correct us, how they correct the assistant, and then adapt to that and behave in the way that the user. We do that as humans. I know that there are certain questions that I can ask one friend, but another friend might get annoyed, and I learn not to ask those questions of those friends. So we need to learn in the same way how to adapt to our users.
Yeah, I love that adaptive design. And there are so many different areas like where the same thing could be done, like what the users like, what they don't like, and how much they want, and all of those things. So when the companies are already understanding and collecting so much information, I feel it's easy to design an adaptive solution like that, for sure. Now, let's talk a little bit about from the user standpoint. When they are asking something, there are n number of ways the same information could be asked, right? For example, what is the weather in Seattle? Do I need an umbrella? Or will it rain today? They all mean the same thing in the user's mind, right? So
Right.
how does this NLP system work? Or how can it make sense out of all of these different utterances, what the user has said, and still give the user what they are looking for?
Right. That is the big question for natural language understanding. We typically, when someone builds a system like this, well, first of all, there are 2 different kinds of systems. There are systems that are trained statistically from many examples, and there are systems that are crafted by rules. And very often a system will start with a rule-based example, and then after it collects data from hundreds of thousands or more interactions with users, then we've got enough data to switch over and build a statistical model, which can be more robust, but requires more interactions, more data to train it in the first place. So typically we would sit around makes it sound too casual. A conversational designer or someone who's designing the system would imagine what are all of the different words and phrases that someone might use in asking about the weather, to use your example, and then build those into the system so that it can respond to all of those. Now they will have forgotten they will have overlooked some examples or some particular ways that they personally don't think of to ask about the weather. And so one of the key steps is, after you deploy a system that might have been initially rolled out with rules, is to collect the data of what are people asking and what do we learn about what they expected for a response, and then train a new system, either by augmenting the rules or by training a statistical system that can handle all the variety of requests that are being asked. But in all cases, it's a matter of anticipating what are all the different ways people can ask for something, and then building a system that responds appropriately to those. In the beginning, before you have a lot of data that's going to be informed by the UI designer thinking of what are the things that they can do, but then you have to quickly, in a beta or an early phase, you need to collect a lot of data about how are people using it. But we did that at Amazon. I
remember that.
Yeah,
I remember that with the music skills and all.
Yeah, exactly. So that in the beginning, we had to anticipate how are people going to ask for this, and then once we launched, we went into an internal beta and then slowly rolled it out while we were collecting lots of data about how are people talking to it, and then augmenting the capabilities.
Interesting. You brought up the Amazon testing, and I still remember people signing up for these slots where they were playing around with music and timer and other skills, and they were just saying naturally what they are. It was very interesting to get all of that thing in place. So wow, you must have got a lot of data from the employees only.
Oh yeah, we did. We had a big. Oh, this won't work. This won't be helpful for the people listening on audio. But I'm showing you an award that I won for using my beta Echo device. I can't remember, 4,500 utterances. I think that was this award that I got.
Wow.
There were incentives internally to get a lot of these devices into employees' hands. It was fun because I had an Echo in my home for, I don't know, a year and a half, 2 years before we launched. But of course it was highly secret. So we had to hide it in a cupboard if anyone ever came over to the house, and then remember to put it back out. So it was, the whole family was in on the secret, and we were all sworn to secrecy, and we had to respect that. But it was fun. We played a lot of music. We asked for the weather. We did a lot of things. A lot of the things that you can do now were not well developed back then. We couldn't ask for jokes early on. It didn't support a lot of things, but it was still a lot of fun to have that in the house and kind of know that you were one of the first people to use this thing before the world even knew about it.
Oh yeah, I remember that too, because I did sign up for the beta testing, and we had this small puck, the dot, at home, and it was in one of these rooms where no one comes, and we had a lot of visitors back then. We wanted to keep it secret. It was just our family, and I was surprised how much my son used to use it and ask things like, who are you, how are you, and those Easter eggs, and he was peeling all of those different elements what Alexa could do back then. Just small things, not all. But I feel like that's a good way to collect information about all of the data to make the systems more natural. So that was a great experience for sure. Now, if you don't have this big setup, or if you don't have ways to do beta testing, and you still want to create a voice application or a chatbot or something which has to be more natural, then what would you recommend someone to do? Because there's only 4 or 5 ways I could think about something or ways, I would say something to a voice assistant or a chatbot. But they may be different, and culture can play a major role when it comes to asking for these kind of things. For example, I translate everything from my native to English. So there are pauses, there are, maybe I'm running short of a word or something, right? So how can people who have different languages and all help you in designing this solution?
Right. So that's part of the reason Cobalt exists, so that people can come to us, and there are other companies that can help with the design of voice systems. And so people come to us, and we're constantly building systems. We built a number of different systems for different kinds of applications where we have to solve that exact problem. We don't have data going into it, so we have to anticipate the kinds of queries or questions that we will be receiving. And I recommend working with a company like Cobalt or one of the others that are out there who have some experience in this and who know how to anticipate what are the different ways that language can express a particular request. And then work with us or whomever to make sure that you're getting the right feedback to then feed that back in. You want to make sure it's good enough to launch, but it doesn't have to be perfect to launch. You want to build into your plan that you're going to improve after launch. And that's why a lot of people do soft launches. They'll do a beta or roll it out slowly so that they're collecting data, making sure that they don't miss anything big before they go to, a complete wide release.
Yeah, I like the idea of launching with slow launch with beta testing or something like that, because we cannot perfect everything at day one. So we need to think about how can we improve it like over the period of time. And I think that's what Amazon also did when they started. It was just 2 or 3 skills, and now there are like so many skills out there. So definitely, I feel that's a very good idea. So, Jeff, I keep hearing this a lot when it comes to natural language processing. I hear people saying NLP and NLU, natural language processing and natural language understanding, interchangeably. What is the difference between both of these?
One is a subset of the other. So, natural language processing is a broad umbrella term that refers to any computer processing of human language, of natural human language. And it could extend to everything as wide as a spell checker or like applications like Grammarly that are fixing your grammar, or speech processing or whatever. So natural language processing is a very broad term. It just means processing of human language. Natural language understanding is a subset of that. It's a specific part of that that deals with, okay, I've got some, well, let's say text. I've got some text that someone has given me, and I want to understand what they mean by that. That's a specific type of natural language processing, and we call that natural language understanding. Typically, natural language understanding is right now for most applications, it consists of really two things. You want to understand what we might speak in grammar terms as nouns and verbs. You want to understand what are the things people are talking about, and what are the things they're trying to do with those things that they're talking about. So in an example, if I said something like, what's the weather in Milwaukee today? You want to understand really two things. You want to understand, okay, the noun is like the place Milwaukee. That's a specific entity that I'm trying to recognize. That's what I'm talking about, not Florida, not here where I live or whatever, unless I live in Milwaukee. And then you want to understand the verb. In this case, that's a little bit broader than I want to understand. The verb is tell me the weather. So then you put those together. So you want to know, tell me the weather, and the place is Milwaukee. But you could have other nouns. Tell me the weather in Milwaukee next Tuesday. And then there's another noun, another entity that you have to factor into that. So natural language understanding typically is this process of understanding the entities or the nouns and the intents, or this generalization of the verbs. What do we want to do with them? I should say some people, so natural language understanding at its basic definition is dealing with text. There's a variation of it, spoken language understanding, which says, okay, now it's the same thing, but the language that I'm getting is speech instead of text. And so you could do that very simply just by saying, let's convert the speech to text using speech recognition. and then do natural language understanding on that text. But there are also techniques where you can look into maybe the tone of how people pause, things that don't translate well into the text, where you can use the details of people's speech and get this spoken language understanding as well. Did I?
Yeah. So I have too many questions here. Wow. So the first thing is, so is NLU used mostly in like a chatbot or voice application systems, or are they also used in any other systems?
They're mostly, I think when people talk NLU today, they're mostly talking about chatbots or conversational assistants. But you could use the same kinds of principles if, let's say, there are people who automatically score essays for students, and you have to do some level of NLU for that. Or there are people who try to pick apart earnings calls that companies give on a quarterly basis and pick apart what did they say about their changes in staffing or their projections for the next quarter or things like that. So there are people doing NLU to extract information from that. Often it's a form of NLU, and people sometimes just call that information extraction. But it's still a form of NLU. But I think when most people talk about NLU today, they're talking about a conversational interface where you're trying to understand a person's intent that they're trying to give a command or make a request.
That's good to know because I've seen so many people doing NLU, NLP together, like when they're talking about chatbots or even in the architecture, when they are designing the architecture for the entire speech system and how it should work. I've seen people using the NLPs as well. So good to know that they are two different. One is a subset of the other. You did mention spoken language understanding. Now, what exactly is spoken language understanding? Is it different than the ASR, the automated speech recognition system, or speech to text system, what we have these days?
Yeah, so the spoken language understanding typically is ASR, automatic speech recognition, or speech to text, plus this NLU of extracting intents and entities from that. That's usually what it means. Different people might use it in slightly different ways, but usually it means extracting intents and entities from spoken command or in an interaction like that.
So that means if I'm talking right now and I have and ahas and all the like pauses and all of those things, it understands and it like truncates those and then is able to process it further.
Yeah, so that's actually the easy part of the challenge. It's one of the easier challenges in dealing with spoken language understanding is ignoring the ums and ahs. What's a little bit harder is when you and I speak, we are constantly stopping and repeating ourselves or correcting ourselves in the middle of the sentence. I might say to my wife, when you go to the grocery store, can you pick up some milk? No, yogurt. And she understands he didn't mean milk, he meant yogurt. So dealing with these kinds of stutters or corrections or repeats or hesitations, these disfluencies, we call them, is one of the big challenges of spoken language understanding.
Yeah, so there may be many then because depending on the region, people speak differently and they may have their own slangs and different ways they pronounce certain things. For example, in India, I know many people call technology as technology. So being able to even make sense out of those kind of things. So, wow. How do you make sure that the speech recognition system, I would not say most of the speech recognition systems are still there yet. Even it comes to Alexa or Google, they don't understand all of the accents or the languages at this point. So how can we ensure we design a system which understands most of these different languages or slangs or ways or accents for that matter, which users can say?
That is the big question. That's one of the big questions. There are a lot of big questions, but that's one of the big questions for any kind of speech recognition is performing well with a variety of accents and dialects and regionalisms, which you mentioned one example, but there are many examples in many different dialects. So unfortunately, we have to train the system on all of that. So if people are going to pronounce aluminum in the US and aluminium in the UK, and we have to respond to both of them appropriately, we have to know we have to have examples of that. We have to represent that in our pronouncing dictionaries that are used for speech recognition. If there are accents, because the vowels are a little different, the people in Australia will speak a certain vowel differently than the people in the US. We need examples of people in Australia speaking and understanding what those sounds, how those sounds are produced for them. So what that means is we need, whenever we're training a system for speech recognition, we need lots and lots of examples of speech from many different people with many different accents and noise conditions and whatever else, but so that the system can learn that variation. Our speech recognition systems are very good at learning the different variations in pronunciations and noise conditions and microphones and echoes and whatever else. But we need to give them examples of that in the training. And so the big challenge in training is getting all of, so someone might say, oh, you need a bunch of speech to train a speech recognition system. I have 200 hours spoken by one person. Can you train a system on that? Well, that would do a good job of recognizing that one person then afterwards, but not everyone else. So we have to be careful not to get too much speech from any one person, any one region. We have to make sure all genders and ages and geographic accents and dialects are represented well. Can I tell you a little bit about how we did this for Alexa?
Sure thing, yeah.
So we had a huge data collection effort that was just a massive data collection effort where we rented a house in some random city in the US. So let's say we rented a house in St. Louis, Missouri, and people would come into the house. We would have like temp workers that would be scheduled to come into the house every hour all day long. And then we would record them in different areas of the house, speaking a variety of sentences. And we would usually have two people at one time, one person like in the bedroom, one person in the living room in this rented house, speaking different utterances so as they wouldn't interfere with each other. And we would have natural background noise. We might have the dishwasher running. We might have the air conditioner on. We would have people stand. We would typically have a variety of like echo devices in the room, picking it up from different locations. And that would be going on all day long for several weeks. And at the same time, we would have another house in St. Louis that was doing the same thing the whole time. And at the same time, we would have a couple of houses in Portland, Oregon doing the same thing, and a couple of houses in Boston, Massachusetts. And then after a few weeks, we would switch that around. And so over a period of months and months, we had, I don't know, tens of thousands of hours of data from so many different people in so many different settings. And that is the secret. That's part of the secret to how Alexa is able to understand people so well with different accents in different settings and so forth. But getting back to your point, we had to do this all over the US to get all the variety of US accents and ages and genders. We had to make sure that we had a good balance of all the different kinds of speakers. So we made sure we collected all of that data to be able to recognize all those different types of speech. And then we have to repeat that in each, when we go to the UK or Australia, or a new language when we go to Germany or Japan or wherever else. We have to start over again and collect all of that. Now, once we launch, like I said before, once we launch, we now get a wealth of data from people actually using the system. And that's even better in many respects than that data that we collected to start with. But the success for, the key to success for recognizing different types of speakers and accents and dialects and so forth is really in getting lots of examples of speech from all of the different kinds of varieties that you intend to recognize.
That's an interesting process. We did something similar at VoiceBox where we collected. But before I get to that, I want to understand from you that was it like a specific set of utterances which you gave to the users, or was there a narration or something? How do you know just based off like a set of utterances, like you have the entire naturality there?
Well, see, we were especially challenged at Amazon because the project was so secret. We did not want word to get out about what we were doing. And so we couldn't ask people to say, here, I want you to say, Alexa, what's the weather? Or Alexa, play this song. We couldn't say that because that would give away too much about what we were trying to do. And so we made up a whole bunch of plausible but unrelated things where people might be, and we didn't always use, some of them did say Alexa. So we got some examples of people saying Alexa, but we had others that were using other names or asking different kinds of questions just to disguise what we were looking for. But yeah, the people had a script. They had a script of 20 short utterances, like commands that they'd be reading from when they were speaking, doing the data collection.
So that's interesting. So going back to what I was saying, so when we were at VoiceBox, we did something similar to collect as many utterances because we also wanted to improve the ASR systems. So we had rented a place where, there were a lot of people. There was the entire recording setup, like you mentioned.
Yeah.
And then we were collecting as many like different accents as possible. But what we did instead was we had like 10-15 minutes worth of script, which a person has to read. So, and that was random, like a story or something. And they were like different stories, different scripts they had to go through. And it was like 30 minutes to 45 minutes effort with each user. And that way, like we got more things. So what approach would you say is better, giving them a set of 5 or 6? I'm trying to understand how these systems could improve, or what is the secret sauce for the ASR systems to actually work better.
I don't know if there's a real secret sauce. In our case, we chose short utterances, short command-like utterances at when we were training these models for Alexa. But in other times, when I've done this for Nuance or for some certain customers at Cobalt or other places, we have people read short paragraphs. It doesn't matter too much. If you're building a system that just cares about short commands, it's a little bit better to have people read those short commands. But you can get a similar performance by having them read a short paragraph or something. But you don't want it to be too different from the real utterances that they will record. I'll tell you a story. One of the things that annoys me is sometimes people say, oh, I want some short sentences or some sentences that people can read. And so they'll look on the internet for examples of short sentences. And they might come back with a collection of tongue twisters or jokes or something like that. And that's not great because tongue twisters, people don't speak them naturally. They're hard to say. Or jokes, it's bad if they start laughing in the middle of it because they thought it was funny. There's a collection of utterances that are often used in testing the intelligibility of telephone systems. They're called the Harvard sentences, but they are not natural sentences at all. They are limited to 2-syllable words. They have all these, for their purpose, they're kind of unusual sentences. And I've seen people use those for speech training and evaluation. And that's just a bad idea because they're not made for that. They're not normal. They're not natural. You want things to be reflecting as much as possible the speech that people are going to be using the system with that you're building.
That's interesting. So another part which bothers me a lot when it comes to how some of the voice assistants work, especially in the car, there's a lot of background noise. We do have noise cancellations and stuff like that to like taper some of those things, but still there's a bit of noise. So if the speech assistants do not work in that context, we actually tell the user like, hey, make sure there's no background noise and make sure you roll up your windows and all of those things so that we can have a perfect environment for the speech systems to work. Although I am of that belief that it should be the other way around, like irrespective of the environment the user is in, the speech system should be able to understand what the user is saying and not put the effort on them to, okay, turn off your TV, stop your yelling kids to shut up.
Right.
So
Right.
how can we make sure a system like that can be designed? What kind of things can we do to make sure the speech recognition systems understand the utterances in the natural environment as much as possible?
Right. So this is, remember when I described the data collection at Amazon, I said we would have people read these things. And in the meantime, we would go around and turn on the dishwasher and the fans, and we might cough in the background or whatever. that's why we did that, because we don't want to put the burden on the user to say, you have to make your house silent when you're going to talk to this device or in the car, or as you say. It's good for people to understand that if they're having trouble, there are things they can do to reduce interfering noises. But you don't want to go into the system with a defeatist attitude that it's not going to work unless the environment is perfect. You want to step toward the customer. You want to make it easier for the customer, the user, the consumer to use the system. So in the name of usability, that's why I strongly suggest that you anticipate what are the noise conditions or other conditions that you're going to have when people are using the system that you're building, and make sure you build that into the training and the design so that it works in those situations.
So training is one part, right, where you can train the systems to work in these environments. But of course, we know sometimes it may work, sometimes it may not. Are there ways the speech systems can work where we can have the background noise, but now the system knows this is a background noise and they can eliminate it from the actual, understanding of the spoken words?
There's research in that area. It's very challenging to identify and separate out noises from speech. There is research in that area. I don't know that anyone's actively doing that right now, but that is a technique that people are looking into, is identifying noises and somehow extracting and pulling them out, leaving just the speech left.
Yeah. So, wow, we have a long way to go with the speech systems, and it's interesting where we have come, especially with these technologies so far.
We do. People often give rosy predictions that, oh, we will solve all of the speech problems within the next 5 years. And I've been hearing that for 25 years. And all we do is we uncover the next layer of challenges. And I think we'll be making progress in this field for many decades to come. We are not at the end of this.
Oh yeah, oh yeah. This is just the beginning. We proved that this can be done, so which is interesting, and that is one more reason why users' expectations have also significantly changed. Now they expect these voice assistant to work perfectly in perfect conditions and with everything. Now, what are the best practices when you're designing the speech systems?
So I think the best, it depends exactly what system you're building and what you want to do. But I think the best practices are, well, first of all, on the design side, I'm going to recap some things I've already said. Put yourself in the user's shoes. Imagine how they're using it. How do you want the system to behave? Make sure that you've thought clearly through the design of the system. Don't just get excited about building a system without thinking about, is it really the right design? Is it too conversational or too informal or too formal or whatever? So pay attention to the design, or skim on the data collection. Make sure you get good, robust sets of data that reflect the way users are going to speak to your system. And make sure you especially pay attention to collecting a set of data that you can use to evaluate what you're building as you go along. And then don't cheat on the test. Don't look at the test while you're building it. That's the test. Get a sort of a golden test set that represents the way you want it to work, and then use that to measure how well it's performing as you go along and are building it. And then make sure that you are working with people who really know what they're doing. It's easy in this case to say, oh, I can get this tool from here or whatever, and without any real experience, I can build something. We at Cobalt are constantly approached by customers or potential customers who thought they could build something themselves, but didn't really have the expertise and the knowledge and the experience. And then when it goes wrong, they come to us, because building systems is a really challenging thing and not for the faint of heart. It really does require experience and knowledge and insight that comes from years and years of working on this.
Wow, a lot to uncover, a lot of things to think about, especially when designing natural systems. This is great. Thank you so much, Jeff. So if someone wants to learn more about, like, for example, if someone wants to start in this field or is interested in learning about how these systems work or want to start their career in this industry, what would you recommend? What kind of reading should they do, or anything else?
Yeah, well, it depends where they are. If someone wants to get into speech technology in a serious way, I would suggest that they find a good graduate school that has a program and study that if they want to make that their career. If I'm talking to someone who's young enough to do that. If someone's already in their career and they want to get into speech, there are plenty of good books and tutorials online that you can go read. I'm not going to recommend any specific one. There are a lot of good ones that will help people learn about the best practices of both the deep technical side of speech recognition and natural language understanding, as well as the design issues of how to design a system and put it together. And there are good books as well in that area. And I don't want to, I'm really not just trying to promote Cobalt, but there are companies like Cobalt and others out there that are here to help you and guide you. So if you're at a company that wants to get into this, give us a call and we'll be happy to kind of step you through what makes sense and how you might be able to do that.
Sounds good. Yeah, we'll make sure we add some of these recommendations in there. And do you happen to know the name of some of the books which we can put in the show notes?
Not off the top of my head. I can look something up and I can send them to you.
Sounds good. And Jeff, if someone wants to get in touch with you or learn more about you, where can they do that?
The easiest is probably just to find me on LinkedIn. It's not hard to find Cobalt Speech and Language or Jeff Adams. There's a lot of Jeff Adamses, but I think there's only one Cobalt Speech and Language. So find me on LinkedIn, or you can send an email to us at Cobalt at info@cobaltspeech.com, and I read all of those messages.
Sounds good. Thank you so much. It was a pleasure talking to you today.
You are very welcome. I enjoyed it very much.
I'm sure listeners will enjoy it too.
I hope so.
Thanks for listening today. If you would like to post a voice comment, please go to www.witlingo.com/daa. That's www.witlingo.com/daa. We'd love to hear from you. Remember, you can find all the information on becoming a certified voice interaction designer, along with show notes and more, at our website, digitalassistant.academy. That's digitalassistant.academy. We encourage your feedback and questions. Be sure to get in touch by using the contact page at the Digital Assistant Academy's website. We will include the link in the show notes. In our next episode, John Stein, founder of Open Voice Network, talks about standardizing voice experiences. Until next week, take care.